Welcome and let's get started. So in our last episode, we made it sure that we could visualize install object jobs in our world. And we saw that when these jobs are completed, they lead to installed objects in the world that you can actually see. But the objects themselves, apart from being shown on the screen, don't really do anything yet. So today, let's look at what if you could work at something like a kitchen counter. So what if objects were typically places where an entity can perform some form of work? And that's what we're looking for today. And for in particular, we expect these workplaces to be places where entities can craft new or different types of items. So for instance, to get more advanced items, you might need a certain workplace to transform more basic items into more advanced items. And to define the type of work an entity can perform as an object, we will introduce a new type called a recipe. And a recipe is basically an object, a place where you can work, with some input items that lead to some output items. Typically a specific item type, but you could get one or several out of the recipe. And we will do that by having recipes generate craft jobs. And the way this will work is that we will have a world that has a list of recipes that it knows of, and it will try and see which recipes could potentially be performed because the required object is in the world. And if it finds one, then it creates an end-user craft job that will add it to the job queue, and then entities can pick up these jobs. So basically working at an object to perform a recipe will be a job like so many we've seen before, and it means we can also reuse a lot of stuff that we already added to jobs in terms of logic. And this is a bit of a bigger endeavor, so we will split this work into 3 episodes. And in this first episode, we will implement the recipe data type, and we will create tests to make sure that these create the correct type of jobs. Then in the next episode, we will make sure that these new jobs, we can actually resolve them. So we can test whether these, when performed, lead to new items we created. And finally, we will hook it up all in the world, so the world itself can spawn jobs. So let's get started. So let's open up Xcode and make sure we open the normal one, not the beta. Let's open our base builder tutorial and start by creating a new Swift file in our model folder called recipe. And let's start implementing this one. So we will use a structure, and this will have a couple of properties. So first it will have an object. That's the object that it requires to be worked at. It will have a set of required items. So this is basically our input items. This will be an array of item stack. So this can be several item types in various amounts. And we will have a resulting item. So this is what we get out of the recipe. And this is again an item stack. And this is from a data point of view enough to describe a recipe. Now what I want to make sure is that we get a job that we can convert a recipe into a job. So let's assume we have a function called create job. And the job always needs to have a position. We would call this one with a specific position, and this would return for us a job. And this would create a new job with a job call for crafting, but we don't have that one yet. So let's quickly go into a job and create a new job call called craft. And this will create an item stack. Now we need to add this one to the description as well. We have our craft and create a description like craft item stack amount of the item stack item.name. We will create a craft separate of this type. And now if we go back to our recipe, we should be able to choose a job call here called craft. And this will create the resulting item stack at the target position. For now, let's not add any requirements just yet. So let's save this one. Let's try and do a quick build to see if we have missed any requirements. There's a switch job here for the job call that needs to be exhaustive. So that's the one in our entity. This is where we complete all the job types, but we don't have one for craft yet. I think it would be better to simply say, for now, if we pass a job type it doesn't know about yet, a fatal error, good idea. We will just pop this job and log an error message, an implemented job type for the current job call, ignoring job. This way we can add job calls without each time having to make sure that we add a value here as well. The disadvantage is we might forget to implement it. The advantage is that we don't have to go through each and every switch statement to add where it's required just yet, and we can defer that work to a little later. So let's try and see if we can create some tests to help refine our recipes a bit further. So let's create a new file, unit test case class. We will call these recipe tests. Create file. We should add a testable import base builder tutorial. And I think we can get rid of, let's comment it out for now. I think we don't really need it just yet, but we'll see. So let's create a first test. Test create job add. Create a craft job. Okay. And let's see, we need a recipe. Let's create a recipe. This requires some test object. Let's create some test data. Let's create an object that only has a name. Test object. Let's also get some input items. Some required item and an output item. This will be some resulting item These are just to make writing these tests a bit faster. So we will use the test object as the object. We will have required items, and this will be an item stack of the input item, and let's assume we need 4, and the resulting item will be our output, an item stack, an output item, and let's say assume we get 2. Then let's create a job, and this job will be a recipe that create job at position 0. And now we can start doing some assertions. First, let's see if this job is actually a craft job. If it's not, then this test will fail. We expected a craft job, but found something else. Return. However, if it is indeed a craft job, then we will have an unwrapped item stack here, so then we can assert that this item stack, which is what we're going to create, that the item is indeed the output item, and the amount is indeed 2, as defined here. So let's see if this test runs. It runs. And let's see if it passes. So it passes. So we did indeed get a job. Very nice. I do want to have some requirements for these recipe jobs, and in particular the type of requirements. I want a requirement for a position, because I want the entity to be at the object's position when it gets performed. So you need to really work at the object as an items object as a workstation. I also want to make sure that it has item requirements. So I want to make sure that we check on whether this item stack is indeed in your inventory before you can perform the job. And I want to make sure that the object exists I want to make sure that the object that you need here actually exists in the world, to make sure that it is not, for instance, deleted and there's actually a place to work at. So these are the 3 types of requirements I want these to be available in a craft job. So let's write some tests to make sure that that is indeed the case. So the first test would be the position requirement. So let's create a new test, create a job at as a position requirement. And we can use the same recipe. And we can indeed create a job. Create a job at, this time we will choose a different position, so we can test later on whether we get the correct position back. And then, so first let's make sure that our job has a target position that is indeed right, that it is the same as this one. Also, let's make sure that we have in our requirements a position requirement. And we can do this by saying we assert true that job.requirements.contains, and this should take a requirement in, and we can switch on the requirement. And if this is a position, then we return true. Otherwise, we return false. And this basically makes sure that once we go through each requirement in the job, that if any of these is a position requirement, then this will become true, meeting our assertion. But if none of the requirements are a position requirement, we will only get back false, meaning the contains statement will return false, and this will not assert the truth. So let's run this test, and we will notice that the test fails because we're never adding any position requirement. So let's do that now. So let's go back to our recipe, and let's add a property called requirements. And this it will be a calculated property that returns a set of requirements. And for now, this can just be a position requirement. We can also add this one to the job. We will pass in our requirements. And now if we perform the test again, the test should pass. Right. So let's do something similar for the item requirements. So let's create a new test called func test create job at as item requirements. And we will take our recipe and, well, let's use the same recipe yet again. Let's create a job from this recipe. And now let's make sure that we actually get some item requirements back. So let's guard that we have items requirement to be our job at requirements. Dot the first. So we are searching for the first requirement that is of type items. We can get back. Then we can say, we don't need this one. We can just say return true. Otherwise, we return false. If this fails, then we will write fail the test. Get message expected at least an item requirement. But found. Let's see. We can't do that here. No problem. We expect at least an items requirement, and let's return. Then let's see if these items matched. So we will get our item stack out of this one, and if this doesn't work, which shouldn't happen because we searched for one here as well. Let's just be careful. Then we should say items requirement should be an items requirement. Apparently it's something else. Then we can assert that the item stack.item is indeed the input item, and we can assert that the item stack.amount is indeed 4. as we defined that as what is required for this as input items for this job. So let's run the test and see it fail. Because we haven't yet implemented any item requirements. So let's go back to our recipe. And let's make sure that we can also add items requirements. Let's create a calculated property. This returns requirements. And this takes the required items and maps these. Let's see, requirements we create type items with this item stack. So we're mapping the required items to actual requirements, and that means that in this requirements property, we can do it a bit different. We take our result, which is an array of type requirement. Then we initialize it as just this position. In the end, we return this result, and in the meantime, we will append the contents of the items requirements. Oh, this one we paste. And this should work. Now we can go back to our test, and we should now see the test pass, because we have the correct requirement available now. Okay, so let's go to the final requirement test, and that's an object requirement. So let's make a new test. Test create job at as an object requirement. Again, we require our recipe and we require a job. Then we should find this object requirement. So job requirements dot first where the requirement in if this is an object, but this is a requirement we don't yet have. So let's first go back to our requirements and create an object requirement. And this is just called object with an object name. That should be enough. So let's get back to the test. Let's go back to our recipe test. Where is it here? So now we can say case object. If it's an object requirement, we can return true. Otherwise, we can return false. And if this object requirement can't be found, then we fail the test. We have a similar message to the one above. Expected at least an object requirement, and let's return. Then let's get the object out of the object requirement. And let's see, so if this fails, then let's send a message back that the object requirement should be an object requirement. Otherwise return. However, if it is, then we can assert that the object name is equal to our object dot main. Or what did we call it? Our test object on main. Let's see if this test compiles. The check requirements function, this is the same as with the complete function. Let's add a default. And this one should simply do nothing. We can add logger. Unimplemented requirements. See, it is now. Let's see. We have our requirements here. We switch on the requirements. Why can't I use this one here? But just for now say that we have unimplemented requirements and look at this at some other time. Okay, so we have our has object requirement. Let's see if this now compiles. The test fails because we didn't find an object requirement. So let's go back to our recipe and make sure that we don't just have a position requirement, but also have an object requirement. And this requires object.name as the object name. So let's run the test again and see if it passes. Now the test passes. Okay, so let's see where we are. I think we're already working on this for a little under half an hour. I think this should be enough for at least our recipe for now. So we are now able to create jobs from recipes, and we have tests that validate that these recipes have certain requirements. And because some of these requirements already exist, like the position requirement, the items requirement, we don't need to test whether these requirements actually function correctly. Let's go back to our presentation. So we implemented the recipe data type, and we make sure it creates the correct type of jobs. The jobs have correct properties and the correct requirements. We implemented the new craft type. In the next episode, we will make sure that we can resolve craft jobs. That will be our next step. So thanks for watching and have a good day.